We covered enums briefly in PHP 8.1 overview video. In this lesson, we'll cover enums in more detail and see some practical examples. It is recommended but not required for you to watch the PHP 8.1 overview video, but we're going to do an overview of enums in this video anyways, so it's okay if you haven't watched that lesson. In the past, you might have seen, or even in the present, you might see code that looks like this. We have a class with a bunch of constants, and then we use these constants throughout the code. We even save the values in the database in some cases and use it later in the code, whether it's for comparison or for something else. This is not a bad approach, and it is certainly better than hard coding such values that don't really change and remain static. Let's see an example of where we would use such constants. I have an invoice model here that has a single method called all, which simply returns list of all invoices. I also have an invoice controller that renders a simple view within the invoices directory, and we're passing in list of all invoices to that view, and in that view we simply have a simple table to display these invoices. So we're iterating over the invoices and are displaying the invoice number, amount, and the status. This status is the value saved from the constant value from invoice status. So if it's 0 means it's pending, if it's 2 it's void, if it's 3 it's failed, and if it's 1 it's paid. If we open the browser and go to the /invoices page, we see some randomly generated data being displayed on the screen, and these are the invoices that I kind of seeded the database with. What if we wanted to filter it out and only display paid invoices, or maybe display only failed invoices, and so on? One way, of course, would be to hardcode this. So we would do where status equals 1 and refresh the page, and sure enough, we're getting only the invoices with the status 1, which is paid. But this is not ideal because we're hardcoding it. Another way is, of course, to use the constant value, and we would still be hardcoding it, but instead of query and manually putting in 1, we would be preparing the query, and we would do statement, execute, and pass in invoice status paid. And this would do the same thing. We would still get only the paid invoices. Again, this is not ideal because we're hardcoding. We want to accept this as an argument into this method so that we can filter the invoices based on the value that is passed in. So we'll accept the status as an argument here, and we will type hint this as integer because we know that the type of the status is integers. So instead of hardcoding this here, we will replace it with status. And then from the controller, we will pass it invoice status paid. Now, of course, this could be the user provided value, but we don't care about that for this example. We're just going to pass it in this way. Now, one of the problems with constants is that we are only able to type hint it using the type of the scalar value, and that is integer in this case, because in the invoice status constants, we have these as integers. If these were strings, then we would type hint this as string. The problem with that is that it does not really guarantee that the provided value is one of the constants from the invoice status. It could be any other integer. So for example, we have 0, 1, 2, and 3. We could simply pass in any other integer like 99, and this would still work. So if we refresh the page, of course, we're not going to get any invoices, but our code still works. We're able to pass any other integer. Because of this, we usually build some additional logic like validation to ensure that the passed in value is really a valid constant value. If not, we might throw an exception. And this validation would occur in multiple places where the constant is accepted. So you might build some helper function or another class that does this validation, or even validate it at the controller level right here before passing it to the model, and have the model expect an already validated value. But in this case, we're going to validate it within the method. So we'll do some kind of simple validation here. And as you saw in the invoice status, we have this method called all, which simply returns list of all constants. And we can use this to check if the given value is part of this array. So we can do if not in array status invoice status all, throw new runtime exception, invalid status. Now let's refresh the page, and sure enough, we're getting an exception. Now this is not bad, and this is actually a good approach and better approach than hard coding things around. At least we have some kind of validation, and we are using constants instead of hard coding things. So we are forced to pass in a valid constant value. Now Enums comes to the rescue here, which provides a better handling for this. Enums basically let us have a class that has a fixed set of possible values, also known as cases. Enum class is just like a regular class, but instead of class we use enum keyword. And while having constants within the enum class is okay, we can define something called cases instead of using constants this way. So we'll define a case for each value, and the syntax goes like this. So we'll do case followed by the name of the case, which is pending in this case, and semicolon. And we'll do the same for other cases. So we'll have paid, void, and failed. I'm going to comment these out, and I'm also going to comment out this method for now. As you notice, these cases by default have no scalar values like we have for the constants, and we'll talk about the scalar values in just a bit, so bear with me here. Each case is an object of the enum class itself. So these cases are basically objects of the invoice status enum. We can var dump one of the cases to prove that. So we'll go to invoice controller and we'll do var dump invoice status paid. And sure enough, we're getting an object of enum class. And let's ignore the fatal error here because we still have that validation within the model, and we'll take care of that in just a minute. To further prove that we are actually getting an object, we can try to get the type of one of the cases. So we'll do get type and we'll put in the case in here, and we'll also check it using isObject function to ensure that these cases are actually objects. So we'll paste that in the isObject check. I'm going to add the exit statement here so that we don't get that fatal error. So let's refresh the page, and sure enough, we see that the type is object and isObject returns true. So each case of the invoice status enum is an object of invoice status enum, if that makes sense. These case objects are actually singleton or single objects. What I mean is that if we assign a case to a variable, so if we do something like status1 equals paid and then status2 equals also paid, and then we try to compare status1 with status2 using the identity operator, it would return true because these two objects are actually the same instance. So if we do status1 triple equals status2, this will return true. Let's comment this out, refresh the page, and sure enough, it returns true. If we change one of the statuses to something else, like failed, then it's going to return false because now we have two different cases, which means two different objects. Because we're working with objects instead of some scalar value constants, we can actually add type hinting where enum case is expected, which is one of the main benefits of using enums. So instead of type hinting it as integer, we can actually type hint it now as invoice status, and because we already saw that each case is an object of invoice status enum, any case that we pass in here will pass this type check. So if we go to invoice controller and we're passing 99, of course this is going to fail because 99 is not an object and we're expecting an object of invoice status class. So we're forced to change this to one of the cases. So let's change it to invoice status failed, refresh the page, and we're getting another fatal error. That's because we're trying to call that all method within the model that I forgot to remove from here. And this validation actually is no longer needed, so we can safely get rid of it because we no longer need to validate or verify that this status is part of one of the invoice statuses, because we're now type hinting and we know for sure that passed in value is an object of invoice status. So we know that it's a valid status, which removes the need to have this explicit validation. So we can get rid of it. Let's refresh the page now, and we're getting another fatal error, which is okay. The object of invoice status could not be converted to string. If we look at our usage, we are using the invoice status enum directly in the execute method here, and this is trying to convert this into a string, and it fails because we're working with an object. What we need is that we need to somehow access the scalar value of the status enum, because in the database the status is saved as integers. It's saved as 0, 1, 2, or 3. So to make this work, we need to somehow assign the scalar values to our cases, because right now cases have no scalar values assigned, they're just objects. This kind of case that has no scalar value is called a pure case. And an enum class that has pure cases is called a pure enum. So invoice status currently is a pure enum. We could back these cases with the scalar value the same way we have assigned the scalar value to the constants. So we could do pending equals 0, and now this case becomes a backed case. And an enum class with all backed cases is called a backed enum. So we're going to back all these cases with scalar values. So paid is 1, void is 2, and failed is 3. And to actually make this enum be a backed enum, we need to type hint this enum class with the data type of the scalar value. In this case, we're using integers, so we need to type hint this as int, and it comes right after the enum class name, so we'll add the colon and int. So now, because our enum class has backed cases, our enum is called a backed enum. There are a few rules to remember here, so let's review them. We can't use union types when type hinting the backed enum. It has to be either integer or string, so we cannot do int or string or something like that. It has to be a single data type, and it has to be either integer or string. If we change it to string, these are going to be underlined because they need to be changed to strings as well. So we'll revert that back to int. Also, we can't have a mix of backed and pure cases. So we can't have pending be a pure case while having everything else be backed cases. This is not going to work. As you can see, it's underlining it here, and the error message states that all cases of backed enum must have a value. This means that either all cases have to be backed or all of them have to be pure. And another thing to know is that cases must be unique. It will throw an error if there is a duplicate case with either the same name or the same value. So if we set the paid to 0, this is going to underline, and the error message states that there is a duplicate value in enum for cases pending and paid. So we have to have unique values. And not only the values, we also need to have unique case names. So if we change this to paid, we see that it gets underlined, and the error message states that enum case with the same name already is defined in this class. So now that we have a backed enum with the scalar values, how do we actually access these values? Because that's what we need to fix our fatal error and get that value somehow to be passed into this execute method. There are two read-only public properties that a backed case has. One is the name and the other is value. So if we var dump status name and status value, and we'll let the exit statement here so that we don't get that fatal error. Let's refresh the page. We see that the name is just the name of the case, and then the value is the scalar value of the backed case, which is 3 in this case. The name property also exists on the pure cases, but the value property only exists on the backed case because backed case is the one that allows for scalar values. So we can use this in our execute method, and this should fix our fatal error. So let's refresh the page, and sure enough, everything is back to normal. Now, as you can see, the status is displaying just the status integers, which are the raw values saved in the database. This is not that user-friendly, right? A better user experience would be to display some user-friendly text representing that status. So instead of 3, we want to display maybe declined or failed or something like that. And instead of 1, we would want to display processed or paid and so on. So let's open our view file here. We see that we're just displaying the raw status here. What we need to do is that we need to display some sort of user-friendly text representing the status. Now, to do that, we need to be able to get the invoice status object from the raw status value. So it's kind of like going backwards. We have the raw status value, and we need to get the proper case object from the invoice status. So if we have the value 3, we want to get the failed case. If we have the value 1, we want to get the paid case, and so on. Backed enums implement an internal interface called backed enum. If we open that up in the documentation, we see that it provides two methods, from and try from. Both of these methods accept scalar value as an argument and return an enum case if found. The difference between the two methods is that from method will throw an exception when the case is not found, while try from will return null. So let's make use of the try from method because that's exactly what we need, because that gives us the ability to get the invoice status enum object or the case from the raw status value. So we'll do invoice status try from, and we'll pass in the raw status object. Now, if we refresh the page, this is going to fail. So we refresh the page and we're getting fatal error stating that invoice status could not be converted to string. And this is the same issue as before. We are trying to convert this into a string implicitly because we're trying to echo it out. If we try to get the value, this is going to be the same problem as displaying the raw status value. We're just getting integers. Instead, we want to call some kind of method, something like text or maybe toString, which will take the raw status value and give us a user-friendly text that we can display on the screen. Enums can actually have methods defined within them, and because each case is an object of invoice status enum, we can call methods that are defined on that enum class. So we can create the toString method within the invoice status. So we'll add that method here, and let's simply return some kind of hard-coded value called paid, and let's refresh the page. And sure enough, it works. But of course, we don't want to hard-code anything here, right? We want to get the proper representation of the raw status value. Now, how do we get access to the case value that the toString method was called on? Within this method, we actually have access to this variable. So we'll do var dump this, and let's add exit statement here so we can test it out quick. We'll refresh the page, and as you can see, this variable equals to the case object that the method was called on. So what we can do now is we can use if-else statements to compare, we can use switch statement, or we can use match expression. So we'll do return match, and we'll check this, and we'll match it with self paid, and if it's a paid case, we'll return paid. If it's failed case, we'll return declined. If it's void, we'll return void. And if it's pending or by default, we'll return pending. So we'll do default pending. Let's add the return type here, and let's refresh the page. And as you can see, it is returning the correct status. And we're only getting failed invoices because we're filtering it out here. So we could change this to paid, and we should only get paid invoices. So if we refresh, we're getting paid invoices. Now let's add another method to get the appropriate status color. We can use the match expression there as well. So instead of displaying just paid here, maybe we want to display paid in green, failed in red, void in gray or black, and pending in orange or something like that. So we'll go back to the invoice status. We'll pretty much duplicate this, and we'll call this color, and within the match, we'll simply return green, red, gray, and orange. Now we can use this within our index.php, and we can add some kind of class here. So we'll do class, and we'll simply copy this and put it here and call color. We can extract this into a variable and use that variable instead of calling try from twice, but this is okay for now, just an idea if you want to work on it yourself. So we'll do color green, and we'll do the same for red, gray, and orange. And to make this work, we need to prefix this with color dash, and this should work. Let's refresh the page, and as you can see, we're getting green color. Let's filter by failed, and we should get red. Let's change it to void. We get gray, and let's change it to pending, and we get orange. If you wanted to take this a step further, instead of returning hard-coded strings for the colors, we could use enums for that as well and return enum cases instead. So if we go back to the invoice status, instead of returning the hard-coded values here, we could simply return something like color green, color red, color gray, and color orange. We can create this enum class within the enums namespace. We'll change class to enum. We'll define the cases, and we need to make this a backed enum. So we'll type hint this to a string, and this should be good enough. Let's refresh the page, and it doesn't work. Let's find out why it doesn't work. Let's go back to the index.php, and the reason it doesn't work this time is because we are again trying to treat this as a string, and the color no longer returns string, it returns an object of color. So we'll access the value property. If we refresh the page now, we see that we're back to normal. To make this even better, what we could do is that instead of prefixing this with color, if we were to use this elsewhere in different views, we would have to keep prefixing it everywhere else. So instead of doing this, what we could do is we could simply call a method here called getClass. And in here, we don't need the match expression because we need to simply access the value, but prefix it with the color. So we can do return color dash this value, and this should work. Let's refresh the page, and everything works as expected. We can change it to paid, refresh the page, and it works as well. In addition to having regular methods, we can also have static methods within enums. Let's say that we wanted to get invoice status from the given color. So we'll do public static function from color, and this will accept an object of color, and we'll do the match expression here. So we'll do match color, and if it's green, we'll return self paid. If it's gray, we'll return void. If it's red, we'll return failed, and otherwise we'll return pending. Let's add the return type and let's test this out. So we'll try to call this method from the invoice controller, and we'll try to call it before this, and we'll var dump it. So we'll do var dump invoice status from color, and we'll do color green, and let's refresh the page. And as you can see, we're getting the paid case, which is an object of the invoice status enum class. So it is working as expected. As you remember, in the last lesson, we covered attributes and have implemented attribute-based routing, as you can see here. If you haven't watched that video, you can watch it. I'll leave the link in the description. But we're basically able to register our routes using attributes feature that was introduced in PHP 8. In that lesson, I mentioned that we were hard coding something, but we could use enum classes, but we didn't actually implement enums in that lesson. So if we go to the get attribute here, this extends the route attribute. So if you go into the route attribute, we see that the method is hard coded here. If we open the post attribute, we see that in the constructor, the post is hard coded here. Better thing to do here instead of hard coding, of course, is to use constants. And even better thing now, since PHP 8.1, is to use enums. We can replace this with something like HTTP method post, and we can create that enum within the enums namespace. We'll replace class with enum, and we'll add cases here. So we'll do case get, and we'll set this to get, case post, set it to post, case put, and we'll have, I think, head, and we'll set that to head. And if we had more, we would add more in here, but I think in our examples, I've used only these HTTP methods, so we'll just define these for now. We need to make this a backed enum, so we'll add the type hinting and add the string here, and this is good enough. If we go back to the post attribute, we see that it's being underlined because the parent constructor is expecting a string, and we're passing an enum object, so we'll replace the string type hinting here with HTTP method, and instead of hard coding to get this way, we'll set it to HTTP method get. Now all is left to open the other attributes and replace hard coding there as well. So we'll open put and replace this with HTTP method put. And I don't have the head attribute. Instead, in the home controller, I think we are hard coding it here. So we'll replace that with HTTP method head, and that should be good enough. Now, if we open the public index.php, we can var dump all the routes that are registered to confirm that our router still works. So we'll var dump routes. Let's open the browser, refresh the page, and we're getting a fatal error because I probably forgot to update one of the things. So request method is expected to be type string, the enum was given. Yeah, so I forgot to update our router implementation. So in here where we're using the reflection to get the route method, we're accessing the method property, and the register method is expecting a string. So what we need to do is that because the method is an object of the HTTP method enum class, we can access the value property. Let's refresh the page, and everything is back to normal. Let's use the print r instead of the var dump so that it's not too cluttered, and we'll add the pre tag here. Let's refresh the page again, and sure enough, our routing works as expected and all the routes are registered as before. Alright, let's continue. Enum classes can implement interfaces and can use traits, but it cannot use inheritance. So we can implement an interface within our invoice status, and the implements interface part comes after the type hinting if it's the backed enum. So we will do implement some interface right here, and everything would work as expected. So if we create this interface within our contracts and we refresh the page, everything works as expected. Traits also work in enums, and it works the same way as it does in regular class, except that traits used in enum class cannot have properties. So let's say that we were using some kind of trait here that gives us the invoice status from the color. So let's say that we wanted to move this out from here into a trait. We could call this invoice status helper or something like that. and we could add this as a trait. We could move this method out of here into the trait. So we'll go back to the browser, refresh the page, and everything works as before. Now the thing is, you cannot use properties here. So if we had some kind of property here, this is a valid thing for a trait. You could use this trait in a regular class, but you cannot use this trait in an enum class if it has properties. If we open the enum class and scroll up, we see that it's underlining here, and if we refresh the page, we're going to get an error. Speaking of some restrictions and caveats, let's review some of the things that you can and can't do with enums. Enums can't have state, so no constructors or destructors are allowed. Inheritance and properties are also not allowed. You can't clone an enum case because cases are singleton objects, as I mentioned before. Magic methods are not allowed except for call, call static, and invoke. You can't instantiate enum cases directly or via Reflection API. On the other hand, enums can have public, private, or protected methods, static methods, or even constants. Enums can implement interfaces. Enums can use traits except the traits that have properties. Enums and cases can have attributes attached to them via the target class to target the enum class, and target class const to target the cases. Alright, so this is all good, but how do we actually access all the cases? Because if you remember before, within the invoice status class, we had this all method here, which was returning list of all the possible constants. Now we don't have this method anymore because we commented out. We could of course uncomment this, and instead of returning constants, we could return the cases, and that would work. But that is not necessary because enums come with a built-in method that lets us access all the cases. So we can actually delete this and delete all the constants from here. And the method to access all the cases is called cases. So let me close all these things out of here, and we're going to open the invoice controller, and within here, instead of var dumping this, we're going to var dump cases, and let's refresh the page. And as you can see, we're getting an array that contains all the cases. The first one is pending, then we have paid, void, and failed. This method is available because both pure and backed enums internally implement a unit enum interface. And if we open that up in the documentation, we see the method definition there. I want to mention a couple more things before we wrap up this video. One is that there is a new function called enum exists, which checks if the given enum exists. So we can var dump enum exists and pass invoice status as an example, and refresh the page, and we're getting true. If we pass some other class name that is not an enum, it's going to return false. So let's pass something like invoice class, which is a model, it's not an enum. If we refresh the page, it returns false. And finally, last but not least, there are new related reflection classes that were added to Reflection API called Reflection Enum Unit Case, and Reflection Enum Backed Case. You can use these to work with enum classes using the Reflection API. So this is it for this video. Thank you so much for watching. I'm going to leave the link to the documentation about the enums in the description, so check it out for more information if you want to know more. I hope you enjoyed this video. If you did, please give it a thumbs up, share and subscribe, and comment below if you have any questions or feedback. I appreciate all the support, and as always, I'll see you next time.